All right, so we're going to look more at App Engine and go App Engine. And if you take a look at these, right, like just open up these. Why? Didn't have it down all the way. App Engine Go, pay attention to these little breadcrumbs because sometimes you'll end up in the wrong place. And you might be like virtual machine or see managed VMs, App Engine managed VMs Go. All right, so even though I searched for App Engine Go, when I clicked on what, Hello World, right, took me to managed VMs Go and beta release, managed VM environment. And so that's slightly different than just App Engine.
It also costs.
So products, documentation, App Engine Go, so we're at the right place. So just pay attention to that. And here, right, we sort of have the same directory over on the left just to kind of give you a little bit of a tour of that. You can see this directory over on the left. Quick Start Hello, creating guides, developing. Quick Start Hello, creating guides, developing. Quick Start Hello, creating guides, developing. All right, so that's all the same links. And then when we get in here, we did Hello World already, so we saw how that worked. And what we're going to look at now is creating a guest book. All right, and so creating a guest book, introduction, all of that. Again, I'm just going to kind of point you towards this README right here with all the steps for getting App Engine up and running. All right, and so this folder, App Engine Introduction with Hello World, lists all the steps for getting it up and running. So you want to make sure you do that.
You might want to mention in there too, go getting the App Engine Go files.
Go get App Engine Go files. Yeah, that's a good idea. So if you go to GoDoc and search for App Engine, right, here's App Engine. Import all that right there. So you'll need this code for this stuff to run. So you want to go get that.
It's actually kind of odd there. You can just import App Engine, just plain App Engine there, and not that full thing, and it will work. The App Engine Go App Serve will actually add that in. It acts as if it's part of its standard library because it's got its own install of Go internally. But your IDE will hate you if you just import App Engine. It will tell you that nothing exists unless you use that full path and make sure you go get it.
All right, so let's put that into here. So install Python, install App Engine, create a path variable, and go get App Engine code with this command at the terminal. Note, this URL could potentially change in the future. Find it on godoc.org, searching for App Engine. Oh, I think I have the whole code there, don't I? Ah! Good step. Many minds.
And
What'd I miss?
Searching.
And searching. Searching for App Engine.
and
Potential is potential. You want potentially.
This URL could potentially change in the future.
now, in what directory would we do that command?
Any go get.
Yeah.
Go get automatically goes to your Go path environment variable. So you don't.
Good question.
So it can be placed anywhere. So you can type that in anywhere.
So we're just going to review a little bit of this tutorial and some of the highlights. So creating an App Engine application is easy, only takes a few minutes. Ha ha ha! And we'll use the data store and we'll use Google accounts. Cool. And then development environment, right? There's information about getting set up. Python 2.7, download and install App Engine SDK for your operating system, and that that's the App Engine Go software development kit. And that's it. All the things that stood out to me on that page. That stuff's covered in the setup notes I gave you. And then also using user services. right? So one of the things you need to know about App Engine is where do I find the documentation? I've been teaching you all how to read Go documentation, and that's been right, like nice, like okay, I'm getting a feel for Go documentation. You do have documentation here inside of this website, and so anywhere it says reference is documentation. And so if I scroll all the way down to the bottom and look for Go App Engine API reference, okay, if I click on that, then here is, okay, an index. Sweet, that's looking like, you know, the documentation. However, again, just go to GoDoc. And when you go to GoDoc, search for App Engine. And so here's like App Engine Log, App Engine Data Store, App Engine Memcache, User, Search, right? Different stuff, mail, remote, different services. Wait, I might have just ran out of, no, that's remote's also there, right? Different things that you could do. If I look at this documentation here, package App Engine, well, here's pretty much App Engine package, right? Then we have access token, app ID, data center, access token, app ID, data center. There's actually like a little bit more here for whatever reason than is listed over in this index.
Technically, the area if you go get that, that's technically the area for if you got a server like on some other website like DigitalOcean and still want to use App Engine services. Technically, it still works on App Engine though, so. And it makes your IDE give you your nice helpful code hints.
So that's why there's a difference between this, could be run anywhere. Is that right?
Yeah.
And this is just the stuff when you're running on Google stuff. You don't need like API call.
Yeah.
Is that right? Interesting. So you can look through here and you might be like storing data, data store, and then, you know, when you see the word reference, right? Overview reference. Reference, that's going to be like, you know, give me my index. There's my index. So I can start looking through what are the different functions I have available, what are the different types, what are the different methods attached to those types. Okay, so you can find it in App Engine, but you could also come over here and you could just find it here, right? Like I could go to Data Store and then I could find it. Yes, what's up?
Yeah, sorry to backtrack a bit, but so
How do I set a path variable?
well, not that the version that's on GoDoc is what you would use for anything and anywhere.
Yeah,
So
if you wanted to use
basically-
an App Engine service on your DigitalOcean server, for example,
Then you would use.
then you can using this version from the golang.org App
Yeah.
Engine. But
if
it
you-
also works on App Engine too. It's got like an if statement at the beginning of every function or something that says if on App Engine.
So the GoDoc one you can use. It can do. Yeah. You can use it without needing to use the cloud version.
So yeah, you can use the one that's on Golang, the GoDoc, anywhere on App Engine, off App Engine, whatever. If you got an App Engine project, it can connect to it and use App Engine services. And it's nice normal Go functions, so your IDE can read it. If you just say import App Engine, it will work when you hit Go when you do Go App Serve, Go App Deploy, but your IDE will not be able to find all the files for it, and so it'll tell you it does not exist and give you errors all over your screen.
Thank you.
Cool. So the third step is using user services. And so here we have FUMPT, net HTTP packages being imported, and App Engine user. And
So
so
they're not using the Go app, the golang.org one. They're using just the plain App Engine stuff. So your IDE will tell you that those don't exist. They do exist, but only in App Engine, and your IDE can't find that.
yeah.
So, or you can just use the fully qualified path from the GoDoc, where you had to go get it, and then your IDE will be able to see it, and it still works on App Engine.
So func init as opposed to func main, right? We got rid of that, and package hello instead of package main. So that's part of App Engine. There's no package main or no func main anymore. That's being used by App Engine. So we use func init or package some other name.
I think the package is actually, you can make it main, but it makes sense to not have it be main if you don't have a main function.
There's something right in here.
I don't think
nothing.
it actually says it, but we had tested it before.
Did
and
we?
It was that way.
So here we got the route and then handler, and we get a new context, right? And we're passing in, and the code here is R for request, right? I was using REQ and RES. So I think I'll change that in my code just to keep it consistent. But app engine new context and pass in the request, and then we get back that and assign to the variable C. And then user current, and we pass in the context, and it gives us back a user. So what do you think is happening with app engine new context with that one line, and it gives us back some context that we can then pass into, from package user, some function called current, pass in the context and gives us the user. What do you think is happening with context? What do you think it's doing behind the scenes, huh?
Okay, so
You're putting the request
sounds like
in.
that. It sounds like new context is basically make a new app engine, or make a new. Wait, hang on. What's C? Is C
Just a variable. It's C colon equals.
Just the, yeah.
So I'm guessing new context. Generate set the variable C to be a new response.
So
new
the
context is taking the request.
So yeah, new context takes in the request, and the request is going to have, hey, if there's a cookie coming in at the request, it'll have the cookie, and if that cookie has a UUID and any other kind of things, and then if I could take that context and somehow pull the user out of it, context is kind of doing all that stuff that we were doing. We just don't have to know about it, right? It's like an opaque variable. It's maintaining state for us. It's creating a context. This context is associated with a certain user, right? And it's, all that stuff we did to sort of like, log in, store things in a cookie, get that information out. That's my guess, all that, if we could pull.
It's a big black box.
Yeah.
So your App Engine server is running on some virtual server somewhere in Google's cloud. And they add a whole bunch of extra information to the request when it comes into you. Things like where the request is coming from. They'll actually give you latitude and longitude coordinates. But some of the things they also put in is, have they been logged in with their Google account? So context, when you do App Engine new context, it reads all that extra information that Google had put into that request, that App Engine put into the request, and kind of extracts it all out and puts it into, we don't know what, some kind of format, we don't know. It's just there. So now you've got context, C. It's got everything App Engine needs to do for any of its functions. So now we can say user.current and pass it C, and it can look in there, okay, what's C, what were they logged in as? Oh look, they're logged in as this person. And they don't have to go parsing through the request, which is a bunch of text. They can just look at the context, which has already got it all parsed. Somehow. We don't know how. They've just got, it's a black box.
So new context is basically, it takes in some information from the user, and it generates some sort of form or something that we don't see, but which App Engine can see and use. Right?
Yeah, it's just a bunch of internal variables. We don't know what's in there. It's just App Engine looked at the request and said, okay, we know this, and this about the user. We don't know what's in there. Just that's what App Engine was able to figure out based off the request. And now App Engine can use it for its other functions.
So the App Engine new context function returns a context. So
Stutter.
from package context, that's this part, there's a type context, right? Which is exported, which is why it's capitalized. Value associated with the current request. This is an opaque value, right? So opaque meaning something's opaque, you can't see in. Opaque glass, I can't see into that room. It's opaque, right? So it's an opaque value. But out of that, we're able to pass the context to package user current and see if there's a current user, right? So context, to me, if I just sort of like speculate, it's like doing all that stuff that we were learning with UUIDs and cookies and maintaining state. It's the context for this request. Who's it associated with? What's the data associated with them? Do we know who the person is or not know? Is there a user associated with it or not? Right? So that's kind of just the context of this request. Who's it coming from? Right?
It's a context where information about the user is stored.
Mm-hmm. Yeah, or some unique ID, which would then allow us to retrieve all the user information. Do you think, that's my speculation, do you think?
Yep, although I think it may also have additional information in there, but we don't know. It's completely black box.
So here, if I click on that context, and this is important, it's going to solve a problem for us in the next step. If I click on that context here, it takes me to golang.org, godoc, but then this package, right, context package, interface, and there's like a deadline, there's a done, there's an error, there's a value, which is key interface, so we could store a whole bunch of things in there.
Are those brackets correct?
Yeah. This is a any type.
Takes
Empty
any type
interface.
And returns anything.
Yeah, so function.
I mean, from where I'm looking at it looks like, what's that?
It's empty interface as an argument in, and empty interface as a return value.
To the right of it, the bracket right to the right of it.
Yeah, it's a closing parenthesis.
Right here?
Being bracket, end bracket.
Right here.
See.
For some reason, to me, it looked like that it was half parenthesis, half a bracket.
Yeah, that's projector.
Right, sorry about that.
So you're giving up some of the granularity, and I'm building everything myself, and you just have to accept, hey, this is an opaque variable. I don't know what it's doing, but it looks like it's helping me maintain, state with users. Okay, that's context. And I know that's like, for me, I want to understand everything. When I was like, what is that doing? When I was first learning this. So then we get user current, and if the user is equal to nil, there's no user. We're gonna send them to user login URL. Let me bring up my code so we could actually users hello go, click on it and see stuff. And it's a little bit bigger. I'm gonna change all my R's to response. See if there are any. Oh! Request. See if there are any more R's. That's it, and change all my W's.
Oops.
Not that one. To, what were we using before? Response, right?
Yep.
There we go, request response.
Down. There's another one.
Thank you. All right. So new context, user current. And then we have if user is equal to nil, user login URL. And we pass in the context. And we pass in a request URL string. So we could click on this. From user package, there's login URL. So we could go here and we could go to the user package. And we could look at login URL. And a login URL returns a URL that when visited prompts the user to sign in, then redirects the user to the URL specified by destination. All right, so we give it the context, right? And then we pass in a destination, which is where the user will be sent after they're logged in. And this is going to send them to a login URL. Google, we're using Google authentication, right? So one of the disadvantages of using just App Engine straight out of the box is you have to have a Google account, right? Log in with your Google account. Okay, cool, you're in. There are ways to do things like OAuth, log in with your Google account, your Twitter account, your GitHub account, your Facebook account, or create a profile. You could do that, right? But just straight out of the box, this first example, what we're looking at is log in with Google, which if you're not a user, if there's no user, go log in. And when we're done logging you in, we're going to send you here. Okay? So that's what login URL does. And if error is not nil, then there's an internal server error. And then we're setting the location. Remember I said we're going to have to understand this. And then status found. So status found is 302. And so 302 is going to send it as a get to this location set in the header, right? So that's kind of an interesting chunk of code. right? That you do the header set and the location and then stats found, and that goes back to the browser. The browser receives that, and it's like, okay, that's a 302. I need a redirect, and I redirect to the location set in the header. Kind of cool. And then we return, and then we just print hello and the name. So if I run this, and you can see my imports there, 04201.
No, go run. Go app.
Thank you. There are too many files. It's spooling up, or whatever you want to call it. Firing up.
Yeah, Go app serve is running a copy of App Engine on your computer, which is pretty big.
Hello, test@example.com. I wonder if I have
Clear your cookies to
clear
get
my
to log out.
yeah. So we could go in and look at the resources, look at the cookies, localhost, dev app server login, clear all. And now not logged in, it's asking you to log in. You have to use this example, test@example.com.
Well, you can use whatever email you want.
Really?
Yeah, in this case, this is act as if you're logged in with whatever email you say.
Oh, it does work.
And look at their cookie value there. Looks like it's using HMAC there, doesn't it? It's what email does it say you are? Whether you're not, that's an admin, and then the HMAC. That's what it looks like.
You think that's HMAC, not UUID? Oh, because it's just HMAC and that to bring it back, yeah. Yeah, because if it was UUID, it'd totally look different. I don't know. Some
Maybe.
number they're using.
Yeah, it could be a UUID. They've got different generator.
Yeah, it's impossible to know.
Yeah.
Well, that was cool. So any questions about this code? No. Cool. Let's just make sure there weren't any other little highlights on that page that I wanted to point out.
When you're doing fprintf with a %v, %v does the Go standard way of printing, which will check for a string method on whatever type it is. So u is actually a user struct, which has a bunch of data in it, well, some data in it, but it also has a string method which lets it be printed without having to call anything particular. Yeah, it's got a bunch of data in there, but it's got a string method, so fprint automatically calls the string method.
So the fprintf.
Yeah, all the print functions in format thumped will look for a string method and use it if possible, if needed.
So if you say to print a user has a string method attached to it which returns a string, and so when you say, hey, print this user, it runs this, and that returns information about the user.
So you can put HTML there.
Yeah, you can put. It's an fprint. You can put whatever you want in it.
We would print it as a string, it would run right.
Yeah, you can put HTML in there. It's just plain string. %v is inserting it at that spot. Yeah, there it goes. You can see you taught you got it highlighted there.
Yeah, so we're putting in user right here, that. And the code, U is that. Kind of cool, U. This is U. All right, that's step 3. Handling forms. So that's the next step. Some habits die behind. Go surf. All right. Let's see what that does. He wrote, "What's up, dog?" So we were able to have a form and then take that and display it on a page, but no cookies, no user information, anything. So let's just see the code on that. We have root and we have sign. And root goes from here to there. Fprint guestbook form. And the guestbook form is a constant, string literal, and it's just a form. And the action is going to go to sign, /sign, so that's where the form gets submitted. The method's going to be post. Can this be uppercase or lowercase in HTML? What's it supposed to be? I thought it was supposed to be uppercase.
Doesn't matter.
Doesn't matter? I'll look it up.
It auto-corrects it to go when it goes to the server.
It worked with both lowercase.
MDN post form. Dude, all of my links. So disappointed. Post corresponds to HB post method. Post. It's all capitalized here, but it doesn't matter, huh? Cap it some upper. Doesn't say. Text area. So text area, name, content, submit, value, sign, guestbook. So the variable coming back will be content, the name of the variable, and it'll have whatever has been entered. And it comes back to sign. So what happens at sign? I want to change all these too. Request. Keep it consistent. All right, execute, and we're executing a template. Sign template, execute, response, request form value content. So whatever that variable was, we're requesting that. And that's the data that we're passing into the template. If we look at, execute here, execute takes a writer and data, and then that data goes into the template. And so that func sign only goes to here, and there's just an error, status internal server error, so it's just from there to there. And then we have a sign template, template must, template new, and this could be any name. And then parse sign template. So it's just another way to parse a single template. It's different from the way we've been doing it, but it's the same idea, right? If you template must, it either has to do it or the application fails. Template new, so we get a new template here, right? And then we're using parse to parse a template in. So if you look at
Parse is good for parsing something in a variable you've got. So whereas we've been using parse file or parse glob, which reads it off of the disk. So just plain parse is good for reading off of a variable that you've got in your text.
I no longer have any of my code completion. I cleared my cache. Don't clear your cache. All right, so here we go. So we were doing like parse files, which gives us a pointer to a template. So template parse files, and then here are the file names are parse glob, and here's the folder with all the files, and we get back a pointer to a template. Well, when we use from package template new, we get back a pointer to a template. Now that we have a pointer to a template, so template new, right? We get back a pointer to a template, and template new just takes in some name, string, allocates new undefined template with a given name. Okay, cool. Back, right? So now that we have a pointer to a template, we could also use parse or parse files or parse glob. Well, here we're using parse, right? So parse takes in a text string and gives us back another pointer to a template. So I talked about that pointer to a template being like a kind of container where all your templates are stored. And you can parse like a whole directory in, and you get back a pointer to a template. Cool, that's where all my templates are stored. And then when I have that pointer to a template, if I want to parse in some more stuff and add it into that container, I could use parse files for that pointer to a template and throw a few more template files into it. So we're just getting a pointer to a template, parsing in text, straight text, and that gives us another pointer to a template, right? That container. So we're just doing that to sign template, and the text we're doing in is just right here. You wrote, wrote, and then output what was written. That's kind of cool. So that's all pretty familiar, and a lot of the code we've already learned is App Engine. We just use that code on App Engine. There's just a few changes. And then there's new packages that we could use, services, which are provided to us to do cool stuff. And so then, then we get to go into the data store and do some things. And so I'm just going to look here to see if there's anything in handling forms. No, I didn't highlight anything. But
So
ready for the data store highlighting? Yeah, baby.
Everything's important.
Yeah, it's all important.
So with running a server on your computer or on a DigitalOcean droplet, you've got one server. It's just sitting there. You can use global variables, whatever you like. App Engine, you have no idea how many servers they've actually got assigned to you. You could have, if you got very little traffic, it may just be one server. But if you got like a big website, they may have 20 servers assigned to your App Engine app. So you can't just use like a global variable to store information. You have to have a database, and that's what a data store is.
All right. Didn't I kill the server? Oh, I just wrote stuff to the data store. Whoops.
You can clear the data store if you go to the
Yeah.
9000. So yeah, if you're using Go app serve, you can go to port, was it
8000,
and again you can see the admin console for App Engine, your local App Engine development.
I'll start this over. All right, won't serve yet. All right, so the first thing you need to know about data store is a schemaless NoSQL database. How many people have worked with SQL? Cool. How many people have worked with NoSQL? Cool. So how would you all, that's awesome. How would you all describe, like SQL, I think, relational databases. I've got my tables, I have my key fields, right? And I connect data between different tables with transaction tables. So if I had videos and rentals, if I had videos and customers, I'd have one table, rentals, where each record in the rentals transaction would store my customer ID and the video ID, so I know which customer rented which video, right? That's a relational database. SQL. How would you guys describe NoSQL? For the people who haven't worked in it.
Flat file.
It's what? Flat file. Okay, flat file. How many people feel comfortable with NoSQL? Don't feel comfortable with NoSQL? Or you don't know about it, it's new to you. Schemaless.
It's a really weird thing. It's not a matter of not being comfortable. It's a matter of, I've done it, I use it, I love it. How do I explain it?
Yeah.
It's like JSON.
Yeah.
It's JSON based, right?
Some are.
JSON based.
So JSON is you guys seen of JSON files? It's nested, just key value. That's, and maybe arrays too. That's basically what the NoSQL database is. You can stick arrays and you can stick key value maps.
So if you're coming from a SQL orientation, whoa, that's really big. Reveal in Finder. Right, we talk about tables, records, and fields in SQL. In NoSQL, kinds, entities, and properties.
I believe that's actually different for every NoSQL database.
It
They've all
does.
got their own names. So
Yeah, it
this
does
is
change.
So this is more appropriately data stores names for things.
So wait, the NoSQL, does that mean not using SQL, or is that actually the name?
That's its actual name.
That's actually.
And it means not using SQL. We're not going to be using structured query language to query our data.
So NoSQL, also known as flat file databases, is newer than SQL. SQL's been around for a long time. It's got its advantages. It's got its disadvantages. NoSQL kind of tries to get rid of some of those disadvantages. Like for SQL databases, if you need a text field, you have to tell it what the max size is for that text field in SQL databases. And then when it creates entries, they're all that size. NoSQL, you just say it's a text field. It'll grow, it'll shrink. Who cares?
Yeah, with SQL, it's kind of like the database company, whoever made the database, developed the schema for how the data is going to be stored, right? Like, this is how data is going to be stored. You're going to have to define it. Once it's defined, it's going to be hard to change, right? So there's the Oracle way, there's the Microsoft SQL Server way, there's the MySQL, right? All SQL, but that they all have developed their own schema for how's the data stored, how are the fields table. With NoSQL, it's like you develop the schema, right? And if you want to change your table, you could change your table, or change how what data is being stored, or add fields to the data.
So, for example, often with what we're going to be doing with data stores, we're going to be putting structures in. Just structs. We'll just pass it in, and it's up to us to remember what struct we used when we put that data in, so that when we bring it back out, it unpacks it correctly.
Yeah, good example. That's great. Yeah, so more responsibilities put on you not to screw it up.
So basically, properly labeling your moving boxes, so that way when you're, unloading the moving van, you don't, stick kitchenware in a bathroom.
Yeah, that's good.
Yeah, right.
All right, so kinds, entities, properties. And we'll see it in action. It'll become more clear, and then we'll come back and revisit this slide. And so in SQL, you'd have, like, here's an example, a table of employees. You'd have record E1 and it'd have those fields. And in NoSQL, you might have kind employee, entity E1, and properties. Kind entity properties, right? So that's kind of how, like, your Go code translates to what you're storing in the data store. What kind of stuff am I storing here? I'm storing employee information. So this kind is called employee. This kind is called, write-ups, where I've written up an employee, right? And I'm going to store, like, which employee got written up. This kind is called vendors, where I store vendor. And then that will translate to some struct in my Go code, where that's the stuff I'm going to store, and I'll create a variable of that type in my Go code, where now I'm going to stick that entity into that kind. I'm going to stick that record into that table, right? And each entity that I stick in is going to have fields, properties. So in SQL, we talk about table, record, fields. In data store, we talk about kind, entity, and properties. So, it's just same old song and dance, different words. So we have a greeting. So anybody's going to be able to post some content. The content they post will be a greeting. We'll have who's the author. We'll have the content that they post, and we'll have the date that they post it. From package time, we could get the time. Or that'll be the type, will be type time. That's the type of the date. And so let me just make sure, am I running? No. Run. See it run. Citing the guest book. Hello. Two hard things. Hello, two hard things. Naming things. Hello again. Pooh. I've been reading Pooh, Winnie the Pooh. And here in the data store, hello again, Pooh. Hello, two hard things. Right? And my entity kind is greetings, so I'm storing greetings here. I have some key. Come in, kind of look at that stuff. Entity kind, parent stuff. So let's look at the code, I think, first, and then we'll look at that. So greeting, and then we have root and sign. And this is important, so you might need to run this at the terminal. Go get -u, which updates golang.org xnet context. Because right here they say guestbook, and they want you to pass in a context. And the code, all the code's right at the bottom. Right? Let's see, where is it? Pass in an App Engine context. They're using App Engine context. That was in the code, App Engine context. I couldn't find an App Engine context. I go to package App Engine.
It must be one of the few differences between them.
And I look for context at package App Engine. 99! But that should be like from, well, in their code, it's from package App Engine, there's a context. And there's no type context there.
So that's one of the few differences between the App Engine standard library ones where it's just import App Engine and the one that you can go get.
I'm wondering if it's an error, because even when I look at like Google App Engine API reference here, I don't see a type context.
I see func new context.
Yeah.
It
Returns a
still returns
context
the
dot
context.
context.
Yeah.
And,
Yeah.
So yeah, that may just be an error.
So you might need to run that.
I haven't actually had any problems getting into Data Store. I remember I used to while we were still using it, but I guess they must have updated because it's been having no problems with context.context.
Okay, so when the user first goes here, they go to root. And root runs. So here's root. And we get a new context, right? And then down here we have data store new query greeting. Well, we're doing a query from package data store new query, and we're saying greeting. What's that? What is that? Greeting was what?
Our namespace.
But what's the specific word starts with K? Greeting is our
Key.
kind. Entity kind, greeting. So basically from this table, we're doing a data store new query of this table, this kind, greeting. And then we do an ancestor, right? And guestbook key C. So guestbook key, we have up here, guestbook key takes in a context. So we pass in a context and we turn data store new key, context, guestbook, default guestbook, 0, nil. So the keys are kind of like how we find information. We'll look more at keys, but it gives us the data store keys, so we'll come back to this in a second. Or maybe we should look into it a little bit right now. Let's look at the...
Ancestor queries is kind of one of the more complicated forms of data store manipulation.
Yeah. This is just the example.
Okay.
Yes.
This is
There's
Google's
more
code.
complicated ways of doing it.
Yeah.
Their example, and the reason they do that is because it's consistent. Ancestor queries are consistent.
Yeah. And so here we have a type key. Key represents the data store key for a stored entity and can't be changed, is immutable. And contains filtered or unexported fields, key struct, okay?
So same as in Go, we've got a map from a key to a value. Data store keys are that struct.
And we have a bunch of methods here. And they're all attached to a pointer to a key. So we could get a pointer to a key with new incomplete key or new key, right? And the one we were just using here is data store new key. So we use data store new key. So let's go look at what is the difference between new incomplete key and new key. New incomplete key creates a new incomplete key. Kind cannot be empty. All right. We have our context. We pass in the kind, which is our table, or greeting or whatever. And then parent is a pointer to a key, and returns a pointer to a key. And then we have func new key, context, kind, string, int, parent, and here. You could either pass in a string or an int, whatever the ID was, or whatever the ID you want it to be. All right, so if we look at ours, we did new key, and we passed in a string and 0. So 0 means we're not using int. So here, a new incomplete key is like, I'm not creating the key.
You provide.
You give it to me, right? App Engine. Like you figure out what it's supposed to be. Here it's like, I'm going to say what it is, and here's the ID, or here's the ID. I could give a numeric ID, and it's that, and then this would be empty string, or I could give a string ID, right? And then that'll be the ID, and that will be an empty, that'll be 0, right? I'm not giving an int ID. So new create key creates a new key. Kind cannot be empty. Either one or both string ID or int ID must be 0. I guess we use 0 there.
Empty string.
If both are 0, 0 value, the key returned is incomplete. Parent must either be a complete key or nil. All right, so we do dash store new key, guestbook, default guestbook, 0, and then nil. So parent must be a complete key or nil. All right, so we use guestbook key right here because ancestor guestbook key, and then we're ordering in reverse date, and we're limiting it to 10. And then greetings, we make a slice of greetings. We set the length to 0 and the capacity to 10. So the underlying array will have 10 slots in it. And then we do query, or queue, from new query, get all. And so we pass in the context, and then we give it a pointer to our slice, which holds greeting, which is this.
Don't worry if you don't get it. This particular example is using perhaps the most complicated parts of data store there is.
Yeah.
We'll get back to it and start from
Yeah.
the easy parts
Thank you.
later.
Thank you.
Don't worry too much if this is way over your head.
And then we execute the guestbook template. Yeah, I'll find. I'll probably reorganize my code to do this one after we've introduced storing things in the data store a little bit more in keys and things like that. And we execute the guestbook template, and so that's going to our response. And we're passing in greetings, which is our slice of keys, our slice of greeting. And so the guestbook template must, template new, book, parse, and here's the string, right? And it's going to range over what we pass in, and then it will, for each iteration, we have access to each of these fields, author, content, date. And so we have author, content, and here, you know, is
With just tells, does this exist?
yeah. Why not if?
Because they want. With says, does this exist? If so, inside this, it's just called dot.
Oh, okay. That's cool. And if, you'd have to put author here again.
Yeah.
That's cool. And then content, author content, and they didn't put in date. And then the form again if you want to post some more at the bottom of it. All right. So that was all
6 minutes.
root. And then we have sign, which is where it goes when something posts. So we get the context. And then we create a greeting. Content comes from our form, date, time now. And we aren't doing content. We did content and date. What was the other one?
Author.
Author. We didn't put in author. So that's going to come here in a second. If u is equal to user current, so this is like idiomatic right here. That line can be a little weird if you haven't done a lot of Go. But it's basically declaring a variable, u, and then you could check that in the same line. So this is a statement. So this is one instance where you see a semicolon. Right, so I declare that variable and then check it right here. And then the scope of u is limited. Can you even access it inside here? I think you could
Yes,
if you wanted to,
can.
right?
They are using it right there inside.
Oh, that's right. So the scope is limited to this block, this code block right there. So it's a way to keep your scope narrow. So get that and then check it. So if u is nil, not equal to nil, then g author is equal to u string.
So if you're logged in through App Engine, it'll put the author name on. If you're not logged in, then it'll leave it off and it'll be called anonymous.
So now we're creating a new incomplete key with this context, and then the kind is greeting, and then guestbook key. Right, same thing, returns a new data store key. So data store new key, guestbook. What's guestbook? Greeting is the kind.
It's a kind that's not being used by anything, or doesn't actually have any values in it. Guestbook's just a kind. But it's never has anything assigned to it. It's just there so you can have a key.
Oh, it's just the parent. Is that right?
Yeah,
The parent.
It's just that's only used for a parent key.
So when we do,
yeah, they're using the most complicated way of showing this off that they possibly can.
when we do new incomplete key, what new incomplete asks for is context, kind, and parent. So here's the context, here's the kind, and we're saying this is the parent key. Well, we got to get a new key here for the parent key. It wants a key, pointer to a key. So to get the parent key, right here, we do a new key, and new key wants context, kind, string, or int. So context, kind, string, and then it does not have a parent. So this one does not have a parent, so it's nil, right? And so parent keys allow you to have
Related. They basically let you relate another table to some other table.
It's like folder hierarchies, right? So greeting is inside guestbook. So we have a guestbook, and inside that guestbook we have greeting. What else might we put inside the guestbook? I don't know.
Cover, title, time.
Well,
Timestamps on the messages.
yeah, but the guestbook would be like, hey, you could have a greeting in here, you could have a review. And so the parent of review might be guestbook. Guestbook has both a greeting and a review, two different tables, two different folders inside guestbook. So if you think about parent-child's like folder structure where guestbook can hold this stuff, that totally helps, right? And then we put that. This is it right here. This is the magic. Data store put, context, key, data, right? The address of our greeting. That's it, and it puts it. And either does it or there's a status internal error, right? And then we just redirect to root, and we say, hey, there you go. Your stuff's been stored. So the hard part there is the key.
In the query, which we won't get to queries until much later, I think. They are complicated.
And this right here, creating a guest book using the data store. I want to leave you with this one thing before you head out, because maybe you got a little bit overwhelmed. And I want to give you a little bit of information, which is nice. But read through this between now and Wednesday using the data store. I'll put it up as homework and give you the link. But this is really nice, right? Storing data in a scalable web application can be tricky. A user can be interacting with any of dozens of web servers at a given time, and the user's next request could go to a different web server than the one that handled the previous request. Like, you don't have to worry about scaling. You don't have to worry about where is my data, what server is it on. Like, if you want to build one application to run on one box, great, right? Because my data's stored in that one box. Every request comes to that one box. But if you want it to actually be a scalable application that could scale to many boxes, where's the data? Which box is it on, right? Which request handles it? You know, who's handling this request? Who handled the previous request? How do you keep track of that across many machines? So this does all that for you. So I think that, you know, that's a really nice thing. It's a nice thing. And this page describes it well, but it takes a little bit of time to wrap your head around. So just remember that you have entities and like greetings, and the entity corresponds to kind of like a table. No, you have kind, like greetings, and that corresponds to the table. And then you have entity, and that's kind of like a record, or, you know, like, hey, I created a value of this type, right? and then you have the properties, which corresponds to the fields, and then you do it kind of like a folder structure, parents and children. So that'll help you when you read through this document. So much for giving them an hour to work.
Oh, it doesn't help when you use those built-in examples.
Catching the Lewis
Sometimes.
Yeah, that ancestor query is